This is section 8.2, part B, vectors in the coordinate plane. The unit vectors in the direction of the positive x-axis and the positive y-axis are denoted by vector I, which ends at coordinate 1, 0, and vector j that ends at coordinate 0, 1, respectively. Vectors I and j are called the standard unit vectors. So vector I will always start at the origin, have a length of 1, and run along the x-axis. Vector j will start at the origin, have a length of 1, and run along the y-axis. These vectors can be used to express a vector v in the form of a and b as ai plus bj. The vector sum of ai plus bj is called the linear combination of the vectors I and j. So we're saying if we break these down, what parts would they be if we add them together to get the whole vector again? Let DE be the vector with initial point D at -2, 3 and terminal point E at 4, 5. We need to write DE as a linear combination of the vectors I and j. To do this, we're going to write this in component form. So vector DE, remember to write it in component form, it's x2 minus x1 and y2 minus y1. Your vector, your initial point is your x1, y1, your terminal point is your x2 and y2. So I can say 4 minus -2 and 5 minus 3. So in component form, this would be 6 and 2. If we write this as a linear combination, it would just be 6 times vector I plus 2 times vector j. So that means we would need to move 6 units along the x-axis, then move 2 units along the y-axis, and if we combine those 2 unit vectors, then we would end up back where the initial one ended if we were to move it to the origin. We need to find the component form of the vector v with magnitude of 10 and a direction angle of 120 degrees. So if we draw our vector on a coordinate plane, 120 degrees is 30 degrees past 90, but we need to break this into the different components. We have the x component, how far out it goes, and we have the y component, how high it goes to get to that point. To do this, we're going to have to know the angle that is located inside this triangle. Now, to get to this part of the y-axis is 180 degrees. We've already gone 120, so that means we have 60 degrees left here. Now, this is your x component. This is your y component. Remember from trig, the sine of theta is equal to y over r. The radius in this case would be our 10. So I can say the sine of 60 is equal to y over 10. Right now we have y divided by 10. To get the y by itself, we're going to multiply both sides by 10. And we're going to get that y is equal to 8.7. To solve for our x, remember that the cosine of theta is equal to x over r. Or we can say the cosine of 60 is equal to x over 10. To get the x by itself, we're going to multiply both sides by 10, and we're going to get x is equal to 5. But if we take a look, that we are ending up in the second quadrant. So if we use the angle, that's going to tell us the length of the triangles, but you do need to orient yourself where you are located on the coordinate plane. We're ending up at this point. So our y value will be positive, but the x value does need to be negative because it's to the left of the y-axis. So when we're done, we will be left with the component form of -5 and 8.7. Again, this is negative because 120 degrees is taking you into that second quadrant. In the second quadrant, your x component is negative, your y component is positive. The direction angle theta of vector v can be found by solving the trigonometric equation. Tangent of theta is equal to the magnitude of vector v times the sine of theta over the magnitude of vector v times the cosine of theta, or you can just do the tangent of theta is equal to b over a if it is in component form or in linear combination. In this case, the a is what goes in the x part, the b is what's in your y component. So if we go ahead and use this tangent of theta is equal to b over a, on the first one this would be our a value, this would be our b value. So I can say the tangent of theta is equal to 7 over 3. To get the theta by itself, we are going to use the inverse. And that'll get us that theta is approximately 67 degrees. We did the same thing on the second example. This is your a value, this is your b value. So I can say the tangent of theta is equal to -5 over 4. Remember, to get the angle by itself, you do the tangent inverse. And that's going to get us for this one that theta is approximately -51 degrees. A quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40 degrees with the horizontal. What is the resultant speed and direction of the pass? So we have two things going on here. Our first vector is the football player himself. The second vector is going to be the football that has been thrown. Now that football player, which we're going to call that vector 1, is moving forward 5 meters per second. You need to think of the ground as your x, up in the air would be your y. So if he's moving forward, that's a +5, but he's not going up in the air any, so that's going to be 0. Our second vector is our football. Now if we break down our triangle over here, ignore how fast the football player is running, we need to look at that football. And it's traveling up at this angle of 40 degrees at 25 meters per second. You need to find your x coordinate and you need to find your y coordinate. Now remember, cosine of theta is equal to the x over r, or the cosine of 40 is equal to x over 25. To get the x by itself, we are going to multiply both sides by 25. And we're going to get that x is 19.2. We're going to do the same thing with your sine to find the y value. So we can say that the sine of 40 is equal to y over 25. To get the y by itself, we are going to multiply by 25 on both sides. And we're going to end up with that y is approximately 16.1. This should make sense that it's going more forward than it is up, since it is only at a 40-degree angle. Now we're looking for the resultant of this. Now resultant just means we combine the two vectors. So our resultant vector is going to be vector 1 plus vector 2. Remember, when you add vectors, you just add the components so they're in the same location. So 5 plus 19.2 is going to give us 24.2. And 0 plus 16.1 is going to give us 16.1. Now we want to find the resultant speed and direction. So we need to figure out the magnitude to find the speed, and we need to find the direction. Now to remember to find the magnitude, we're going to do the square root of a squared plus b squared. In our case, that's going to be the square root of 24.2 squared plus 16.1 squared. And that's going to give us a magnitude of 29.1 meters per second. Then you need to find your angle. Remember we said that the tangent of theta is equal to b over a. This is our a value, this is our b value for our resultant vector. So tangent of theta is equal to 16.1 over 24.2. To get the theta by itself, you do the inverse of the tangent. And that's going to get us that theta is equal to 33 degrees. So this means the resulting vector of the pass is about 29.1 meters per second at an angle of about 33 degrees with the horizontal.